Okay, so next I have one here that you might actually know off the top of your head which of these it is, but I want to pretend that we don't already happen to know what this graph looks like, and think through what properties of a graph we can read off and then compare to the functions over here. So let me just start by noting that the x-intercept of this function is 0, 0. The y-intercept is 0, 0. But actually, the same is true of both of these functions. The x-int here is at 0, 0, and the y-intercept here, So in particular, all three things we're looking at, the graphed function, f, and g, they all have exactly one x-intercept and one y-intercept, and in all cases, that x-intercept and that y-intercept is at 0, 0. So I want to suggest another thing you can look at to help you sort these out, namely whether the inputs and outputs are positive or negative. So for the graphed function, I want to point out positive input gives me a positive output. Okay, and that's because the positive inputs are over here, and all of these inputs give me an output here that's up here, which is on the positive y-axis. Similarly, negative inputs, those give me negative outputs. And again, I can see that here's the negative inputs, and they're giving me negative outputs because this graph is landing on the negative y-axis. Okay, so how are we going to sort this out? Well, what I recommend to do is to just try a positive input and a negative input for each function. So f of 2 is 8. F of minus 2 is minus 8. G of 2 is 16. G of negative 2 is 16. Okay. The key difference here is this sign. Okay, note I'm circling the absence of a minus sign here, or if you want, I can put a plus sign there, just to emphasize this. Where did that come from? Well, when I cube minus 2, I have minus 2 times minus 2 times minus 2. So I have 3 minus signs. 2 of those minus signs cancel. They leave me with that minus sign. When I look at minus 2 to the 4th power, I have minus 2 times minus 2 times minus 2 times minus 2. That's 4 minus signs. That's 2 pairs of minus signs that each cancel. And so after all the cancellation, there are no minus signs left and it's positive. So the thing I want to look at to definitively answer this is that the graphed function has negative inputs giving negative outputs. But if I look at just this pair, I see that indeed f, my negative input, has given me a negative output. But for g, a negative input has given me a positive output. And so this tells me the graphed function can't be g. Okay, so let's look at this graph. This one is pretty similar to the previous graph in that if I look again, positive inputs give me positive outputs, and negative inputs give me negative outputs. And so if we look over here at f, if I go to put in a positive number to f, so something like, let's see, f of, and let's say, I don't know, what's a positive number I'd like to evaluate this function at? 9. F of 9 here is 3, because the square root of 9 is 3. What if I take f of negative 9? Okay, that's going to be the square root of negative 9. But this is something I cannot do. This is undefined. And so really it turns out that when you're looking at a graph, there are really 4 possibilities for what you could see in terms of outputs. You could see that the output is positive, the output is negative. If you're looking at an output of 0, that's corresponding to x-intercepts. But the output could also be undefined, in which case you would see no graph at all over that portion. But that's not what happens here. And so, in fact, f is undefined for all negative inputs, unlike the graph. So the graph has to be g. So you might ask, how exactly does this end up working with the cube root of x? So you'll notice we're done the question. I never even had to think about g of x even a little bit, because I already, after I wrote down my properties of f, I already saw that it couldn't be f, so it must be g. But just to clarify, what does happen if I take g of a negative number? So in this case, I'm going to take negative 8. It'll give me the cube root of negative 8. Okay. And it's really tempting, because square roots of negative numbers don't exist, to just assume that this is undefined. But it's not, because what is the cube root really asking you for? The cube root is asking you for a number whose cube is, in this case, negative 8. And so negative 2 is, in fact, such a number. Okay. Why? Well, this is the same thing we talked about in the previous example. When I cube negative 2, I actually get 3 minus signs. 2 of those minus signs cancel, and I still get negative 8. And so the graph of cube root of x ends up having this tail over here, unlike the graph of square root of x, which looks like this. Okay. And there's this blank void over here, and in this blank void, we're seeing that the function is undefined. And really, this is a distinction between even roots and odd roots. Okay, so a square root is really a second root, so 2 is even, so we can't do this. We end up with this undefined void over here. Whereas cube roots or fifth roots or seventh roots, those you'll be able to take for negative values. And so that's really what has happened in this particular example. Okay, so here we have one more example of using positive, negative, and undefined inputs and outputs. So here, if I look at the graph, I see that negative inputs give positive outputs, and I see that positive inputs, they give undefined outputs. Okay, again, I'm seeing undefined because there is no graph here on this side of the y-axis. Okay, so I recommended, if you're trying to sort this out, plug in some positive and negative numbers, see what happens. So if I go to plug in f of 4, I get 1 over the square root of 4. And that is 1/2. And now if you came across this on the homework, you should be jumping for joy, because in fact, we're already done. Why are we already done? Well, I took a positive number, and I put it into f, and I got a positive output. Whereas, if f were actually the function that was in the graph, I would have gotten no output. It would have been undefined. Okay. And so I can just finish up my answer here. And so we're done. I did just want to make one note here, which is that it's really tempting when you see this piece of g, that is when you see a square root of minus x, it's really tempting to say that this is actually undefined all the time, because you can't take a square root of a negative number. I just wanted to show you why that's not true. Namely, I wanted to look at what happens if you actually did take g of a negative number. So let's say we took g of minus 9. Then we would get 1 over the square root of minus 9. But this is what happens. Minus 9 is actually plus 9. So then this is a third. Okay. And that's how it ends up being, that this is the graphed function where it's defined for negative inputs, but not defined for positive inputs. Because if x is positive, this negative x is negative, and so its square root is undefined. All right, I'll wrap up this video for now. In the next video, we'll talk about our last feature that you can use to tell graphs apart, which is increasing and decreasing, and what that looks like in the graph. But, for now, I'll see you next time.